Hello everyone, welcome to today's class. We'll be continuing with the properties of Trigo, okay, and we'll be doing some extra questions. Let's start with this question. Okay, now for this question, again, the limits, if we see, the limits are from 0 to 1. So there's no pattern of minus a to a, so not a question of odd even. So what I'll do is, I don't know anything, so I'll apply king rule again. So replacing x with, add the limits, 0 plus 1 minus x, that means 1 minus x. So this is your integration I, so this is also your integration I as 0 to 1. X will be replaced by 1 minus x. This one again replaced with 1 minus 1 minus x. Okay, I've replaced this x, and then power is n. So basically it becomes integration 0 to 1, 1 minus x, and if we solve this we get x raised to power n. Okay, so not every question is regarding adding the I and I. There's no way you can add this first I with this second I that we have created. Okay, but if you look at this, why is this beneficial? Because right earlier it was 1 minus x raised to power n. We could not open that, but now it's only x raised to power n. So we can multiply, and if you can multiply, we can solve this further. So this becomes integration 0 to 1 x raised to power n minus x raised to power n plus 1. Add the power. This becomes x raised to power n plus 1 upon n plus 1. Limit 0 to 1 minus x raised to power n plus 2 upon n plus 2. Limit 0 to 1. That becomes 1 raised to power anything is 1. So this becomes 1 minus 0 upon n plus 1 minus, again same thing, 1 minus 0, upper limit minus lower limit. So solve this further. So you'll get n plus 1 n plus 2. Okay, here n plus 2 minus n plus 1, also n minus 1 basically. N and n cancels, 2 minus 1 is 1, so answer is 1 upon n plus 1, n plus 2. Okay. So sometimes after applying king rule, you literally have to solve the question. Okay. Let's look at next question. Zero to pi by 4, not pi by 2 this time. 0 to pi by 4 log 1 plus tan x. Okay. Again, there's no sense to use odd even property because limit is not minus a to a. So we'll use king rule. I told you most of the questions are from this rule itself. If we use it, what is going to happen is it generate. First of all, let's decide x will be replaced by 0 plus pi by 4. So pi by 4 minus x. And your new integration will be integration 0 to pi by 4 log 1 plus tan pi by 4 minus x. Okay. What is tan pi by 4 minus x? That we have to think. So we are going to use property of a minus b, because directly this is tan x, this is tan pi by 4 minus x. So directly you cannot do anything about this right now. Okay. So let's open it. 0 to pi by 4 log, this becomes tan pi by 4 minus x is tan a minus tan b. So tan a means tan pi by 4, which is 1, minus tan b, tan x, upon 1 plus tan a, again 1, tan b is x. Okay, I've used tan pi by 4 as 1. Let's take the LCM. 0 to pi by 4, let's take log. If we take the LCM, this becomes 1 plus tan and 1 minus tan, so 2 upon 1 plus tan x. Okay. All right. Now 1 plus tan x. I think the question also has 1 plus tan x log, but that was in numerator. This is in denominator. So let's split it. Okay, so 0 to pi by 4 log. I can write this as log 2 minus log 1 plus tan x. Log a minus log b is log a by b. So I'm using reverse of it. Okay. Let's break this dx. Now I forgot to write dx. Okay. Let's break this in two separate integrations. Dx minus integration 0 to pi by 4 dx. Now this is I. If you look at this part 0 to pi by 4, no, this is also I. So this is basically I is equal to something minus I. So take this I on the other side. So basically I plus I is equal to integration 0 to pi by 4 log 2 dx. Okay. Log 2 is constant, so we don't have to solve. So 2I is equal to, take this log 2 outside, integration 0 to pi by 4 dx log 2. What is integration of 0 to pi by 4? Integration of dx is x, limit 0 to pi by log 2 is outside, pi by 4, this is 2I. So I is 0 to pi by 4, this is pi by 4 minus 0, so only pi by 4, and divided by 2 pi by 8, so pi by 8 log 2. All right, next question. Again, you can see we cannot multiply this as such. If we want, we can write, but the problem is there is a square root on two terms and we cannot integrate it even if we do this. So go for king rule. X will be replaced by 2 minus x. So the another integration becomes integration 0 to 2. This x will be replaced by 2 minus x. And if we do 2 minus x here, so 2 again will cancel, it becomes root x. So it's kind of like the same question like we did for 1 minus x raised to power n into x. Na? Same thing is happening with square root. Okay, dx. Now we can literally multiply this. So this becomes integration 0 to 2. This becomes 2 into x raised to power 1 by 2 minus x raised to power 3 by 2. Okay, root x is power 1 by 2. So integration, let's integrate. So 2 is constant, let it be. X raised to power 1 by 2 is 3 by 2 into 2 by 3. Okay. I'll put bracket, and limit is from 0 to 2 minus this is x raised to power 3 by 2 plus 1, 5 by 2 into 2 by 5. Again limit is 0 to 2. So this becomes 4 by 3, 2 raised to power 3 by 2 minus 2 by 5, 2 raised to power 5 by 2. Okay, upper limit minus lower limit is 0, so 0 into 0 power anything is 0. All right, I think this can be further solved. Let's generate. What is 2 raised to power 3 by 2? I can write this as basically 2 raised to power 3 complete raised to power 1 by 2. So basically root 8, that's 2 root 2. Similarly 2 raised to power 5 by 2 is 2 raised to power 5 complete raised to power 1 by 2. 5 is 32 and 1 by 2 means square root, that is 4 root 2. So let's rewrite this. 4 by 3 into 2 root 2 minus 2 by 5 into 4 root 2. You can take root 2 common, or if you want you can directly solve this as 8 by 3 root 2 minus 8 by 5 root 2. Take the LCM, 15. So 40 minus 24, 16 root 2. This is the final answer. Yeah. All right. Let's see the next question. Now this time the question is looking very lengthy, isn't it? Pi by 0 to pi by 2, 2 log sine x, log sine 2x also. Okay. So before even starting the question, I think we should adjust this 2 logs. There are 2 logs present, so we can combine. The problem is this 2, because of this 2 we cannot add. So what I do, I'll take this in the power, and problem also is this, that here x is going on, here 2x is going on, so we'll have to adjust. So let's rewrite this as I as integration 0 to pi by 2. Take this power, so this becomes log sine x whole square minus log sine 2x. Okay, dx. Now this log minus log becomes log a minus log b is log a by b. Okay, dx. This is inside a single log now. 0 to pi by 2 log. This I can rewrite this as sine x square, and sine 2x is 2 sine x cos x. So sine x cancels. Okay. So this becomes integration 0 to pi by 2. If you look at that sine by cos, we can write tan. So log tan x upon 2. Remember, tan x upon 2, not tan x by 2. This is the difference. So again I can write 0 to pi by 2. This is log tan x, na? So log tan x minus log 2. Do we really need this? What was the question? Okay, weird. So there is no sense of looking at the question. This is our new question now. I is this. Okay. Well, let's keep it as it is if we want. Log tan x. I want to do like this also, because I know I can integrate log 2 separately and log tan also, but I'm thinking whether I should directly do this also. Let's try direct. By splitting you can always try. If that doesn't work now, so I'll split this log in 2 parts. Let's try direct first of all. This is nothing going to happen, so we'll directly use king rule. So this is 0 to pi by 2 log tan pi by 2 minus x is cot x upon 2 dx. That will work. This is also I've replaced x with pi by 2 minus x. So tan pi by 2 minus x is cot x. Now add them. 1, 2. Actually same thing is going to happen even if you split it. 0 to pi by 2 log a plus log b is log tan x log tan x into cot x upon 2 upon 2. Okay, dx. Tan and cot is 1 by tan, so it will cancel. So this becomes integration 0 to pi by 2 log 1 by 4. Okay, dx. So I'm taking this as a constant, so take it outside. We don't have anything now. Log 1 by 4, 0 to pi by 2, 1 dx, and right side is 2i. 2y is equal to log 1 by 4. If you want, you can write this as 4 raised to power minus 1 and get log 4. Okay, and you can write that as also 2 log 2. Again, depends on the question. Integration of 1 is x, so upper limit minus lower limit, so pi by 2 it will come. So I is coming minus log 4 into pi by 4. Okay. Further, if you want to simplify, what you can do is I is equal to pi by 4 negative log 2 square, get this 2 here, sorry, pi by 4 now. That was pi by 4. I told you log 2 na, that we can adjust that. So minus pi by 4 into 2 log 2. So 2 cancels. Fine. Minus pi by 2 log 2. Again, they can leave your, mostly said like the maximum simplified answer is this. Okay. But as such, this was also a correct answer. But again, it depends whether the option is given like this or not. Okay. And usually they will give this kind of option. All right. So good question as such, using log, properties of log a lot. So you have to be very comfortable with properties of log while doing these kinds of integration. Again, now finally property minus a to a. So we have to check even odd. And what last class I gave you notes like sin x is odd, but the power is square. So odd square is, odd is like negative, negative square is positive, that means even. So this is an even function. That means I cannot say the answer is 0. So what is the result? Integration minus a to a fx dx is 2 times integration 0 to a. Okay, so you basically do 2 times integration 0 to a fx dx if fx is even function. So I know this is an even function, so I can directly write this as 2 times integration 0 to pi by 2 sine square x. And I think you know this was the first question of definite integral while doing the properties. We applied the King rule and we add it. I'll show you. Properties, and look at this. This was the question. It was cos square, but the idea is still the same. Sine square was there or cos square, because the moment you apply King rule, it will become it was cos square, so it becomes sine square. So the question is sine square, so it will become cos square. Adding them will get 1. So answer will be still same. Answer will be pi by 4. Okay. So answer of this also is directly pi by 4. That's complete answer is pi by 2. Okay. If you want, you can apply King rule and add. It will work. All right. Next question. Integration 0 to pi x dx 1 plus sin x. Okay. So integration 0 to pi. Not odd even, nothing is there. And usually, like for these kinds of questions, the hint itself is there, not a substitution. I'm talking about King rule again. Okay. You'll see like whenever x is there and trigonometry is there and definite integral is there, effectively, you'll have to apply King rule, and somehow after King rule this x will get eliminated, because then you have 1 upon 1 plus sin x. 1 plus sin x can be integrated as long as we don't have x in the numerator. Okay. Let's see what happens in the King rule. King rule, if we apply, so x will be replaced by 0 plus pi minus x. So replace it. I is equal to integration 0 to pi. Numerator becomes pi minus x dx 1 plus sine pi minus x. 0 to pi minus x is pi dx, sorry, pi minus x dx. 1 plus sine pi minus x is sine x. That's your first integration I. This is your second integration, also I. Add them. Adding 1 and 2. What do we get? 2i is equal to integration 0 to pi. X denominators are same. So x plus pi minus x, if you add them, what do we get? Pi. Okay, pi dx upon 1 plus sine x. And now it's a simple question to solve. Okay. As such, what you can do, take pi outside, and 1 plus sine x you can integrate by directly rationalizing it. Okay. Because this is something from indefinite integral. Whenever you see 1 plus sine 1 minus cos in the denominator, just rationalize it and automatically you'll get the result. Okay, so let's solve it. Now 2i is equal to, I'm taking pi outside, integration 0 to pi 1 upon 1 plus sine x, and rationalizing it, 1 minus sine x, 1 minus sine x dx. So 2i is equal to pi, numerator becomes 0 to pi 1 minus sine x, 1 minus sine square, a square minus b square, so 1 minus sine square becomes cos square dx. So 2i is equal to pi 0 to pi. How to integrate this? The idea is, again, this was a direct question in indefinite. What do? Split the denominator, single denominator. So 1 upon cos square, that is, I'll write it, I'll show you the steps if you are not able to recall, minus sine x by cos square, so I'll write cos x dx. Okay, so pi times integration 0 to pi, this is sec square x minus sine by cos is tan, 1 by cos is sec dx. And now this is integrable. Okay, 2i pi 0 to pi, sec square integration is tan x. Okay, and this integration again 0 to pi, and this integration is sec x, again 0 to pi. Okay, so 2i is equal to pi times, and pi is being completely multiplied here, remember. So tan pi is, that you should know, tan 0 is 0, tan pi is also 0, 0 minus 0, minus sec pi. So first think for cos pi, cos 0 is 1, cos pi is minus 1, so do the reciprocal of that. Cos pi, sec pi will also be minus 1, minus sec 0 will be 1. So 2i is equal to pi into minus 1 minus 2 plus 2, so 2 pi. So I is equal to pi, I pi. Okay, done. All right, this is done, this is done. Let's look at this question. Zero to 2 pi cos raised to power 5x. Okay. Now look at the question and try to think which property, because as such 0 to 2 pi is there, so you might think king rule. Of course, go for king rule, because 90% time the question is all about this king rule itself. Okay, let's see. So what I'm going to do, I'm going to replace x with 0 to add the limit 0 and 2 pi, so 2 pi minus x. Okay, so integration 0 to 2 pi cos raised to power 5 2 pi minus x. What is 2 pi minus x? Cos 2 pi minus x, 0 to 2 pi. This is 360 minus, so this is in fourth quadrant. Fourth quadrant, cos is negative, power is also odd, so negative will come out, so minus cos power 5x. Okay. Now point is the function is generated same, it's just that it is negative. Okay. Now I told you a property. Let's go to the property first. See this integration, last one, 0 to 2a. This integration, see what you have to do. You have to first of all replace x with 2a minus x, means add the limit and replace it with 2a minus x. If you get the same function after king rule, we get the same function, so you have to do this 2 times 0 to a integration. But if you get minus of fx after applying king rule, the integration is directly 0. This is the property, last one. So remember this, the last property is like this. After king rule, if you get the same function, just do 2 times integrations, limit 0 to half, whatever the limit was, just do half of that limit. But if you get negative of fx, the answer is directly 0. So for this question, I'll say since f of 2 pi minus x is minus f of x, so integration 0 to 2a fx dx is 0, because f of 2a minus x or 2 pi minus x as such a minus x is minus f of x. Okay, this is the condition that you have to recall. So you don't have to solve anything, answer is 0. All right. Next question. Okay, lot of terms. Sin x cos x, 1 plus sin x cos x, 0 to pi by 2. Okay, what you can do, even if you apply king rule, it will become just sine will become cos, cos will become sine, and yeah, it's a good thing. We should always try king rule. We'll see now. Although question is looking slightly complicated, I was also thinking. So in definite, if you can't see anything, just go for that king rule. Again, replace x with pi, add the limit pi by 2 minus x. So your new integration becomes integration 0 to pi by 2. Okay. Sin pi by 2 minus x is cos x. Cos pi by 2 minus x is sin x upon 1 plus sine will become cos, cos will become sine dx. This is our I, this is also I. Okay, 1, 2. Denominators are same, na? Add them. Adding 1 and 2. So we get 2i is equal to, look at the numerator, sin x will cancel sin x, cos x will cancel cos x. So 2i is equal to 0. Integration of 0 is, we don't have to solve anything, it's 0. So 2i is 0, I is also 0 again. Okay. Kind of like the same idea, even by don't adding, you can say because this was a function and you applied king rule, you got negative of the same function. If you take negative common, you will get, this is nothing but minus fx. So you can directly say that the integration is 0, or you add them, automatically they become 0. Okay. All right, this is done, this is done. Okay, now comes the best question of definite integral. Lengthy question, kind of subjective also in the way. I'll tell you which result you have to remember, that will help. Okay. and this question teaches you all about the properties of definite integral. Okay, this is your I. So I is equal to 0 to pi na, so let's apply King rule. Replace x with pi minus x. So integration 0 to pi, this becomes log 1 plus cos pi minus x is minus cos x. Okay, dx. This is also I. This is also I. Add them. So adding them, what do we get? 2i is equal to 0 to pi. Then 1 log 1 plus cos x and plus log 1 minus cos x. Dx. Okay, so 2i is equal to integration 0 to pi. Log can add. In addition, log a plus log b. While doing the addition, it becomes multiplication. So log 1 plus cos into 1 minus cos, that is 1 minus cos square, and 1 minus cos square is sine square x dx. Okay, what I have done is multiplied them, and 1 square minus cos square is sine square. You can take this 2 down also in this. So I'm taking this outside and cancelling this with this 0 to pi. That becomes log sine x dx. Okay, so I is integration 0 to pi log sine x dx. So far we haven't even started with the real part of the question. We just adjusted it. Again, we cannot see anything, so what we'll do, apply the King rule again. Replacing x with again pi minus x. Okay, so again I get integration 0 to pi log sine pi minus x is sine x. Okay, so after King rule we got same function fx. Your integration function is still the same. So what is that? This is the property, integration 0 to 2a fx dx is 2 times integration 0 to a fx dx if f of 2a minus x is f of x. Means after applying King rule, if you get the same function, you have to do 2 times the integration and make the limit half. So your new integration is 2 times 0 to do the half of the limit. So half of this is pi by 2 log sine x. Okay, I think it will take a long time. I'll put a box here also. I okay, I'll number the page. Like this is like the first page, this is the second page, because we'll require another page. Now again King rule, third time. So this time this I will become 2 times 0 to pi by 2 log sin x will become log cos x, because x now will be replaced by, add the limit, pi by 2 minus x. So this will become log cos x. Mark this as your first, mark this as your second. Now I'm starting with the third page as such. Okay. I'll add it here. We have space. So 2i. Okay. Adding 1 and 2. Okay. We got 2i is equal to 2 times integration 0 to pi log sin x plus log cos x. Now addition is going on, so log addition is log AB. So I'm starting here now. 2i is equal to, that's your page 3 of this. Okay. So 2i is equal to 2 times integration 0 to pi. This becomes log sin x into cos x dx. And integration limit is, sorry, by mistake I've written pi. It was pi by 2. It was pi by 2. Now, the moment you see sin and cos together, you should be able to recall that 2 sin x cos x is sin 2x. So I'm multiplying by 2 inside the log and I'm dividing by 2 inside the log. Okay, so 2i is equal to 2. Okay. Okay, let's cancel this 2. It's going to take a long time to be solved. So cancelling this 2 and 2. So I is equal to 0 to pi by 2. Numerator becomes log sin 2x. Denominator becomes 2. So integration 0 to pi by 2 log sin 2x minus log 2. I can write this. In subtraction it becomes division, so division becomes subtraction of log. Okay. All right. So far we don't have any problem. Okay. All right. Now split this integration in two parts because log 2 can be integrated directly. So integration 0 to pi by 2 log sin 2x minus integration 0 to pi by 2 log 2 dx. Okay. This can be done because that's integration is log 2 is a constant, so just apply x with it and upper limit minus lower limit. So that will give you minus pi by 2 log 2. Okay. And this, what will this give you? We cannot integrate so far with this. Okay. I forgot to put dx in it. Yeah. Dx. So now we have to solve this integration. Now in order to do that, what I'm going to do, I cannot integrate log sin 2x directly, so I know it's a weird step, but you'll understand what is going to happen afterwards. Let 2x is equal to t for this. Okay. For this part we have already done. If 2x is t, 2 dx is equal to dt. There is no present, there is 2 not present here, so we'll multiply by 2. Space is required. We have some space. I'm shifting this here. Yeah, so now multiplying by 2 and dividing by 2. Okay, so I becomes 1 by 2 integration 0 to pi by 2. Let's use the substitution 2x dx. Yes, 2x dx dt. So this becomes integration 0 to pi by 2 log, no, we are doing definite integral. So if I'm changing the variable, I should change the limit also. So this is something from the first lecture of definite integral. When your lower limit is, if we want to change the lower limit when x is 0, okay, your t is 2 into 0, so 0. Upper limit when x is pi by 2, your t is 2 into pi by 2, so pi. Okay, so this becomes change the limit 1 by 2 integration 0 to pi log sine t dt. Okay, 1 by 2 is there. All right, so this is done. Minus pi by 2 log 2, that we have already solved. Okay, this is also your I. Again applying king rule here. Should we apply king rule? 0 to pi. 1 second. 0 to pi log t sine pi. One minus cos. Okay. I'm marking this statement 1 2 na, marking this as a third statement. Okay, remember that I was 0 to pi log sine x integration dx. This is a third statement. Okay, I'm going to use this. Right now it's log sine t dt. There is something you should know that again a property, third page is almost done, na? So here fourth one, this is the fourth. So I is equal to integration a to b fx dx is same as integration a to b ft dt. Means the name of variable has no sense in definite integral. So whether I write sin t dt or I can replace again this with sin x dx, it's same thing. So this becomes I is equal to 1 by 2 integration 0 to pi log sin x dx. Okay, and this thing I'm highlighting, this was your I. This is your I, na? Integration 0 to pi log sin x dx. This is being generated here again with 1 by 2 in it, and minus additionally what was going on, pi by 2 log 2. So I is 1 by 2 into, this is another I, minus pi by 2 log 2. Okay, so take this on the left side. So I minus I by 2 is minus pi by 2 log 2. So we never really integrated the whole function, we just used property and somehow we generated sine again. Solve this, you get again I by 2 is minus pi by 2 log 2, and I is equal to, cancel this, minus pi log 2. Okay. That's your answer. So I've numbered this. So lengthy question, yes, okay, but king rule once, king rule twice, king rule thrice, I think. Here 3 times we applied the king rule. That's why it's the best question. All the properties are used in this, and you understand the use of the first property, like what is that you can change the name of the variable. Okay. All right, we are done with basic definite integrals. We have seen the proper integration through it. Now let's deal with mod, because definite integral particularly deals with mod also. Okay. Let's take this question. I'll solve one question, then I'll just open the expressions for the remaining. You can solve the remaining part. We have this question. I'll solve this one first. Okay, integration minus x minus 1 in mod 0 to 4. The problem is you don't know, because mod x can be x also, mod x can be minus x also. It depends whether x, the quantity inside it, whatever is inside the mod, and that is x here, is greater than 0 or less than 0. This is the definition of mod. So I'm not sure whether I should open this with positive or negative. If I cannot even open the mod, how can I integrate? You see the problem. So how do we decide this, whether it is positive or negative? So we'll be using the concept of AOD increasing decreasing. You solve this inside quantity x minus 1 equal to 0. You get x equal to 1. You plot this on the number line. Remember critical point we were doing like that. Then you decide whether the thing is positive or not. We have number line is now being divided in two parts because of this point 1. More than 1, less than 1. So put anything more than 1 inside this. If you put more than 1, let's say 2 or 3. 3 minus 1 is positive. So mod will open with positive. So the quantity inside is positive, so mod will also open with positive. Okay, like this. If you put anything less than 1, so let's say 0, 0 minus 1 is negative. So negative. That means for any value of x greater than 1, it is going to be positive. Any value less than 1 for x, it is going to behave as negative. Okay, this is something from AOD increasing decreasing, if you can recall. Now, the point is we are integrating from 0, let's say is here, 4 is here. Okay, so this mod from 0 to 4, it is behaving negative as well as positive. So what we'll do is we'll break this integration of 0 to 4 in two parts. Remember one property I told you that integration a to b fx dx can be integration a to c fx dx plus integration c to b fx dx. You can break down the integration in two parts. Same thing I'm going to do. I'm going to break this in two parts, 0 to 1 mod of x minus 1 plus integration 1 to 4 mod of x minus 1. And now we can open this mod because from 0 to 1 it is going to be open with a negative sign, minus of x minus 1 0 to 1 dx plus 1 to 4, it is positive, so it will open with also positive. So directly opening it, this was mod So one mod we have opened with positive, one mod we have opened negative. The reason is that mod is changing sign in between the integration limit. And now you solve this. So basically minus x na, minus of, you'll do it x square by 2 minus x square by 2 minus x, and you solve upper limit lower limit in 0 to 1 here, 0 to 1 here. Okay, plus this also is x square by 2 minus x, solve the limit 1 to 4, 1 to 4. That's it. Putting the value, solving it, that's the whole point. Okay, upper limit minus lower limit. So solve this now. Let's see. If we solve this, this becomes negative of 1 square is 1 minus 0 is 0. So 1 by 2 minus, this is 1 minus 0, so 1. So 1 by 2 minus 1 is negative half, so that becomes positive half. Plus this becomes 4 square is 16 minus 1 square is 1. 15 by 2 minus 4 minus 1, 3. So this becomes plus 1 by 2 plus 15 by 2 minus 3. So 16 minus 3, such big value. There's something wrong. By 2 is there, 0 to 1, 1 to 4. 1 minus 1 by 2, 4 square, 16, 16 minus 1, 15 by 2, oh, minus 3 is there, no? So, oh, it's correct, 16 by 2 is 8 minus 3, that's 5, that's correct, okay, yeah. All right. we're done with this. Now I'm going to show you two more questions of mode, but I'm not going to solve it completely. I'm just going to tell you how to open it, because that's the main problem that students struggle with. And then I'm going to use one typical problem far greater than this. I think two levels are there in mod. Look at this question. Again, integration is x plus 2, so solve it equal to 0, number line minus 2. Your integration is actually from minus 5 to 5, na? Minus 5 to 5. So we have to decide more than take any number more than minus 2. So more than minus 2, like we've taken 3, 0. So 0 plus 2 is positive. So for more than minus 2, it is behaving as positive. For less than minus 2, it will be a negative. Also, you can recall that there was a pattern of positive, negative, positive, negative. So directly. So now you just open the mod. So integration you will do minus 5 to minus 2. You'll open the mod with negative sign, dx plus integration. This will become 2 to 5. You'll open the integration with positive sign. Rest I think you can solve. X square by 2, 2x, x square by 2, 2x, upper limit minus lower limit. Okay, this was the solution for fifth. For the other one, what you do, solve it equal to 0, put it on the number line 5. Now again the pattern, we don't have to even think now, positive, negative, we know. Okay. So 2 to 8 now we have to do. So again 2 is here, let's say 8 is here. So I have to break the integration in two parts. So integration 2 to 5, it will open with negative sign, minus of x minus 5, plus integration 5 to 8 with the positive sign. X minus 5. Okay. All right, this is done. Let me deal with mod first. There are two more questions. Then there is this question, and it has a very simple idea. What you do is, there's a misprint, this is also mod. What do you do is, you do it like this, 1 to 4 mod of x minus 1, 1 to 4 mod x minus 2, integration 1 to 4 mod x minus 3, and you solve three separate questions, number line for this, number line for this, number line for this, 1 2 3, positive, negative, positive, negative, positive, negative. Okay, I'm not solving this, I'm just again giving you a hint for this. Now this integration is already from 1 to already from 1 to 4. So in the interval of 1 to 4, this is behaving positive. So we'll open it also with positive. So not necessarily every time it has to break down in 2 integration, because your limit is itself from 1 to 4. So 1 to 4, this is positive x plus 1. But for this, 1 will be less than 2. So 1 to 4 will be like this. Here also 1 to 4 will be like this. So this integration will, second one will break in two parts, 1 to 2 with the negative sign, 2 to 4 with positive sign. Okay. Similarly, the third integration will break in two parts, 1 to 3 with the negative sign, and 1 2 3 with positive sign. Okay, positive sign means don't put anything. So 1 2 3 and 3 to 4. Okay, and then you solve it. Calculation wise, I know it's slightly tricky. Also, in 1 marker MCQs, these questions will be for a single one, not for multiple one, but I'm teaching the concept and I'm extending the concept to this kind of question also. All right, this is done, this is done. Now let's deal with this question. This is sort of a theoretical question in a sense, and if you read it and you'll see this question, the problem is that the function is not given to you, so you might think, how will we actually integrate this, or how will we get the result? Okay. Now this question can be created like this. First of all, they'll put k here and they'll say find k. Okay, they'll say that 0 to a fx gx dx is equal to k times 0 to a fx dx if fx is defined like this and gx is defined like this. Now there is no function right now present, and you have to use, again, clearly this is question of property. So let's start 0 to a. I'll start from here. We'll generate this and we'll see what factors comes in. 0 to a fx dx gx dx. Okay, I have to do this. I cannot think of anything else. Again, one property to save us all, king rule. Okay, so 0 to a, this is, we have to replace x with a minus x. So f of a minus x plus g of a minus x dx is equal to, sorry, not plus, this one, they were in multiplication. Okay. Dx. This is what we have to integrate now. Now as per the question, it is given f of a minus x is same as f of x, so I can replace this with the help of this. So this becomes integration 0 to a fx. Okay, and what about this g of a minus x? So of course this has to be dealt from this expression. So what I'll do is I'll write plus, into 4 minus g of a minus x dx. Okay, all right, this is our integration I going on, this is also I. So let's multiply. What else we can do? Sorry, my mistake. If we generate g of a minus x out of this, we get 4 minus gx. So this will be 4 minus gx dx. Let's multiply fx with this. 0 to a, this will be 4 fx minus, I'm breaking into integration, 0 to a fx gx dx. Okay, what is this as such? This was the question itself. Look at this, same thing. So this is I. So I is equal to integration 0 to a 4 fx now, so I'm writing 4 outside, minus I. Get this I on the other side, so I becomes 2i. 0 to a fx dx, this 2 and 2 cancels, so I becomes 2 times integration 0 to a fx, and this was the k that we were looking for, because as per the question this is k times 0 to a fx integration. So this is k is 2 answer. Okay. So again you can see the power of king rule. Kind of weird looking question, but easily dealt with this. Okay. All right. Let's look at one more problem. I'll put it in the MCQ form. 0 to pi by 2. Options are given like this. Okay, we'll see. You should have given answer in terms of pi, I think, but let's see. So this is a question 0 to pi by 2 log 2. Anyway, let's apply King rule. Replacing x with pi by 2 minus x. Oh, I got it. This is I. So another I gets generated, that is log. So what will be, what is going to happen? Sine pi by 2 minus x will become cos, and cos will become sine. This is also I, this is second, this is first. If we add them, 2i. So log, what is going to happen? They will get multiply. Log will get multiplied. So 4 plus 3 sine x upon 4 plus 3 cos x multiplied by 4 plus 3 cos x upon 4 plus 3 sine x. Cancel, 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 cancel. Integration 0 to pi by 2. So 2i is integration 0 to pi by 2 log 1 dx. What is log 1? 0. So the whole answer is 0. Integration is also 0. That was I was thinking that they should have given the option in terms of pi, because I know something happens and pi comes out, but 0 is also an option. Okay. All right. Fine. Now, one last modification of mod, I'll tell you. Do we have that as a question? Let me check. We have that. Okay, got the question. This one. Look at this. -1 to 2, but this time the function inside the mod is not a linear one. So far the linear one were easily dealt. Still the same idea. You solve it equal to 0 and get those critical points. The problem is this time the function is complicated. So x cube minus x equal to 0. You have to solve that. So take x common. X square minus 1 equal to 0. X plus 1, x minus 1. You get 3 values of x. One from this 0, one from this minus 1, one from this 1. So your number line itself has now 3 critical points. That means we have to check. Okay. So 0, minus 1, 1. And if you want, you can check by putting the test values, like put 2 in this and check whether it is coming positive or negative. Put anything between 0 and 1, check it's coming positive or negative. But I'm telling you this pattern still follows because they are all linear expressions. So positive, negative, positive, negative. I know that pattern will follow. Change the sign at every critical point. Okay. Now we are actually integrating from where to where? We are integrating from -1 to 2. So -1 is here, 2 will be here. They could have given you -2 to 2 also. Okay, but anyway, as long as we have this sign, we can open the mod. So now integration will be broken in multiple 3 parts here. -1 to 0, 0 to 1, 1 to 2. So first of all, -1 to 0. Your mod will open with positive because the quantity is positive. So x cube minus x plus 0 to 1. 0 to 1, the quantity is negative, so you open this with negative. Plus 1 to 2, and you open this again with positive. So x cube minus x. Okay. Rest is just solving part. Okay. This is x raised to power 4 by 4 minus x square by 2 plus, not even plus, let's deal with negative, minus x raised to power 4 by 4 plus x square by 2. This is x raised to power 4 by 4 minus x square by 2, and you have the limits. This is minus 1 to 0, minus 1 to 0. This one is 0 to 1, 0 to 1, 1 to 2, 1 to 2. Okay. So minus 1 to 0, so 0 is 0, so minus 1 raised to power 4 is 1, so 1 by 4. 0 is again 0, minus 1 square is 1, upper limit minus lower limit, no? So minus lower limit, so still it will come negative. This will also come negative. You can solve this on your own, you don't have to verify with you don't have to solve like this. Take your steps, don't do it in a hurry. Now negative, upper limit is 1, lower limit is 0, so 1 by 4, upper limit is 1, lower limit is 0, 1 by 2. This one 2 square is, sorry, 2 raised to power 4, 16 minus 1, 15 by 4 minus 4 minus 1, 3 by 2. Okay. Minus 1 by 4 plus 1 by 2 minus 1 by 4 plus 1 by 2. Just a lot of time. Anything cancelling? Minus 1 by 2 plus 1 by 2 cancels. That's it. This becomes minus 1 by 4, minus 1 by 4 becomes minus 1 by 2, minus 3 by 2 I'll write first, plus 15 by 4 later. So negative negative again, this becomes minus 4 by 2 plus 15 by 4. So if you solve this, you get this becomes 887. No, there is some positive negative mistake. Let me check the next one. 2, 4 minus 1 by 4, 15 by 4 minus 2 minus 1 by 2, that's 3 by 2. So far it's correct. Positive negative will cancel. Why is this should have been plus 1 by 2. Minus 1 by 4. One second. Yes, got the mistake. This value was not negative. This was actually positive. Because when you solve it, there is an additional negative here. No? I forgot to take care of that. Minus 1, and there is additional negative sign here. No? So because of that negative, it will become positive. So actually they are not cancelling each other. So that's 1 by 2. 1 by 2 is 1. Basically 1 additionally. Now that becomes 1 minus 1 by 2 minus this. So 1 minus 1 by 2 is plus 1 by 2, and this is negative negative, no, minus 2, so minus 1 basically. If I solve this, minus 1 plus 15 by 4, now you got 4 and 11 by 4. Yeah, that's the correct answer. Okay. So be very careful. Just one single sign, negative, positive, and it becomes but again, you will not get these kinds of very lengthy question so often. Very rarely that happens. Once that happens, you have to be very careful, but you should be comfortable with at least single mod questions like this. Okay. All right, that ends the session for today. See you in the next class. Good day everyone. Bye.